In this video we're going to examine the mechanical mixing of moist air and ask what happens if we take two moist but unsaturated air parcels or air masses and mix them together isobarically, that is at constant pressure. What's the net result? That's shown schematically on the right, where we have two air masses M1 and M2, with their own specific humidities, mixing ratios and temperatures given by the subscripts, but the same pressure. And so when we mix them, the total air mass will have mass M1 plus M2, and the specific humidity, mixing ratio and temperature will have new mixed values, but at the same pressure. The easiest to consider is the specific humidity. The specific humidity of the mixed mass is simply going to be the mass of the vapor from both air masses divided through by both masses in total, which gives you the total mass of the new mixed air mass. But we know we can write the mass of vapor for both of the initial air masses in terms of the specific humidity and the total mass of each of the initial air masses. MVI is equal to QI by MI. And so substituting that into the equation for the mixed specific humidity gives you the result that the mixed specific humidity is the mass weighted mean of each of the specific humidities of our two samples. It can be shown, it's a little bit more complicated, the same holds for the vapor pressure and the temperature. So let's use that result then and consider these this curve here, which is the saturation curve, which shows the equilibrium between condensation and evaporation. So in the yellow region of the plot, that's the unsaturated region where the evaporation is greater than the condensation rate, and in the supersaturated environment where the condensation rate is greater than the evaporation rate. And along the line, this is equilibrium where the two rates are the same, and it's the saturation curve. And what it shows is, because this curve is nonlinear, you can have two parcels of air that have a given temperature and a given vapor pressure, both of which are unsaturated, but when you mix them together in the right ratios, you end up with a saturated parcel. And so one can horizontally mix two different air masses that are unsaturated and get a saturated mass. And this is what happens in things like fog and contrails, and also in what's known as entrainment. Entrainment is the phenomena where a saturated cloud parcel mixes with an unsaturated environmental parcel, resulting in an unsaturated parcel. So you can entrain dry air and detrain cloud mass, if you will, lose cloud mass. In this particular example, we've started with two unsaturated parcels, mixed them together in the ratio shown, and ended up with a supersaturated parcel. So horizontal mixing, in other words, is one way in which we might form a stratiform cloud.